Because he's like looked over us and was like, it's
not football.
When we were doing
All right.
our breaking.
Coline,
What's up?
factor the top first one.
The X on the outside. Right?
Is there a GCF?
No.
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 So it's a regular trinomial.
Yeah.
So find me factors of 5 that add up to -6.
-5 and -1.
Correct. I thought you said you didn't have a clue.
I haven't put on back, I didn't have a clue on the rest of it.
Olivia, car. This denominator.
2 times -5.
2 times -5, okay. So what do I put?
X plus 5.
You said -5. didn't you?
X minus 5. And then X minus 3.
No, you said 2 and -5, didn't you?
Sorry. 2. Yeah,
Isn't that what you told me?
that is what
You told me correctly.
I have it on my paper.
You all in here. Yeah, all of you in here. I'm looking each one of you in the eye. You should be able to do that. So what? Can I cancel now?
X minus 5.
Yeah. So what's my answer?
1.
X minus 1 over X plus 2. That's it. A lot of you forgot the second part here. Identify any X values for which the expression is undefined. That's what I call the restrictions, right? So X is not allowed to equal, what makes that a 0? 5. What makes that a 0? -2. You guys, I thought we're paying attention yesterday. Simple. Okay.
Wait, so for the top one, the denominator, like, do I not need to put 1?
Not need to put 1.
Like, see how it's like, it's X minus 1?
Right. The answer is this fraction.
Okay.
How'd you
And
get
then-
5?
How'd I get 5? You have to look at the original problem. What makes the original problem 0 in the denominator? So +5 would make that part 0. -2 makes that part 0.
Oh, I thought we were
So
done with the crossed out part.
No, that's still part of the restrictions, because that was your original denominator.
Hmm.
Okay? So if we were to substitute -2 or 5 in the original problem, we'll get a 0 in the bottom, and that's not possible. So X can be anything but those two numbers.
Wait, so
Yeah.
you don't have to zero out the numerator?
No, you don't have to worry about it. It's okay to have 0 in the numerator. 0 divided by anything is 0. But you cannot divide by 0. Remember, that's undefined. Grace, factor that numerator, please. Correct. Should we do something else first? Well, yeah, it's gonna end up being X minus 6. Why? What's going on in that top one?
Out of order.
Out of order, right? So let's do this part first. Okay? So we don't like that being there, right? So what did we say yesterday? Yeah, pull it out, right? So I bring the -1 out, I get this, don't I? And then Grace also told us there's a GCF of what? X, right? Let's see if I can move this up so I don't have to squeeze it all in. Okay, so we can factor out, we have the -1, we can factor out the X, and then you told me what? You told me X minus 6, you know what you told me? Very good. Trent. What are the factors of 6 that add up to negative 7? No, don't think of don't do what adds to get 7. What time to get 6? Do that part first. What times what gives you 6? 2 and 3, but do they add up to 7? No. What's another 2 that'll add up, multiply, get 6? Very good. But since it's negative 7, it's negative 1 and negative 6, right? Because when I multiply negative 1 and negative 6, I still get positive 6, right? But when I add negative 1 and negative 6, I get that negative 7. Okay? So, let's do this before we cancel stuff so we don't forget. What's the 2 restrictions? 1 and 6, right? Okay, Olivia? Yeah, why don't you guys do that first? That way you won't forget about it. 1 and 6 are the restrictions. And then I can cancel what? The 6's. So my answer is negative x over x minus 1. And then 1 and 6 is what x is not allowed to eat. That's what we were doing. Isn't that what I showed you yesterday? Yeah, exactly what I showed you. Okay, now I know a couple of the homework problems were tougher because you had an a value that was not 1. But we went through how to do that also. Okay? So, answers to number 2 was 2x to the 6th over x minus 3, and x cannot be 3 for the restriction. Number 3, way in the back. Uh, 2x plus 5 over 2x minus 7. X cannot equal 1/3, and x cannot equal 7/2 or 3.5. Number 4, 1 over 3x minus 1. X cannot equal negative 4 or 1/3. Number 5, negative 1 over x minus 5. X cannot equal negative 4 or 5. Number 6, 2x plus 3 over negative x. X cannot equal 0 or 1/3. 7 is 6x, and there's nothing that will make the denominator 0. So there's no restrictions. And then we jump up to number 18, right? 18 is 4 over x. X cannot equal 0 or 2. 19 is 4 over x plus 5. X cannot equal 1/2 or negative 5. And 20, x plus 6 over x minus 6. X cannot equal 6. Any of those you'd like me to do? Really? You guys are telling me you have no clue, and going over 1 has got you done. You're good? Going over those 2, you're good now? Go ahead, Dan. Or Cole.
Can you go over 3?
Sure. Okay, these had a 6x squared plus 13x minus 5. I want to do each one. Here's the numerator. I'm going to put the denominator over here because it's going to take some work, so you can see both of them. 6x squared minus 23x plus 7. All right, so I have to multiply 6 times negative 5. What are the factors of negative 30 that add up to 13? 15 and negative 2, right? So I'm going to rewrite this as 6x squared plus 15x minus 2x. Those add to give me that 13, but when I multiplied them, I got that negative 30. And then the minus 5. So the minus 5 and the 6x squared stay the same. Okay, now I group them. What's common in the first group, John?
6, 9. The what?
First group.
X squared.
No?
X.
Yeah, what else? What number goes into 6 and 15?
3.
There you go. So 6x squared divided by 3x is 2x, 15x divided by 3x is 5. What do I pull out of here, Zach?
Equal -1.
Good. Negative because that third one's negative and nothing's common, but you gotta put a number, so 1's always common. And then you get 2x plus 5. All right? So what is the two factors, Sydney?
3x minus 1 and 2x plus 5.
Good. So that's that numerator. All right, let's do the denominator. What's 6 times 7? 42? All right. What times what will give me 42? Added gives me negative 23. Okay?
Negative 2 and negative 21.
Right. Negative 2 times negative 21. I should have done this up here. What do we use? Negative, or positive 15 and a negative 2, right? That's what we use. All right, so we're going to rewrite this one. 6x squared minus 2x minus 21x plus 7. Group them. Okay? What's common to the first group?
2x.
2x. 6x squared divided by 2x, 3x. Negative 2x divided by 2x, negative 1. What's common to those two? The 7, but since the 21's negative, I got to pull the negative out also, so I put negative 7. And then I get positive 3x and a minus 1. So what's this denominator? Oh, you dirty. Go ahead, Sydney.
2x minus 7 and 3x minus 1.
All right, 2x minus 7 and 3x minus 1. Do we have any common factors top and bottom? Yeah, 3x minus 1. So they go away, right?
They go cross out.
Right. So before I cross them out so we can see them, I just want to see them so I can do this part. What number for x makes this side equal to 0? 7 over 2. You just opposite of that divided by that. What's the opposite of that? 1 divided by that. So that's our answer. Because those went away.
You can open
Yeah.
You can hold on.
Again, if you're not sure, just write. You're trying to figure out what makes it equal to 0, so just do that and then solve it. Add 7. You're going to add 7 divided by 2, right? Okay? But that's the opposite of that divided by that, right? Okay? All right, we're still going to do this stuff today. Okay? But we're going to multiply and divide these fractions. We still have to factor. Okay? So let's go back to where we stopped yesterday. All right. So we're going to multiply. All right. Factor all numerators and denominators completely, just like we did last night. Whenever you can factor, you factor. Divide out common factors. We just say cancel out, right? You see the same factor up top and up bottom, you cancel it out, right? Multiply numerators, multiply denominators, and you're done. Because if you cancel everything out, you won't have any common factors other than 1. All right? So, do I need to do any factoring for this A problem? Yes or no? No. Why not? Why don't I have to factor in that one? What is not in that one? What symbols pluses and minuses, right? If there's no pluses and minuses, I don't have to factor, it's already factored. Okay, the one on the right has pluses and minuses, right? So then I'm gonna have to factor over there. This one I don't have to factor, so I just start canceling stuff, right? What number goes into 3 and 9? 3, right? So how many times does 3 go into 3?
3.
1. How many times does 3 go into 9? You were thinking of the 9, right?
Yeah.
That's all right. You were thinking right about that. How many times 2 go into 2? 1. How many times 2 go into 10? 5. Now, look at the x's. How many x's are up top? 8. How many x's are in the bottom? So where's the x going to stay? Top. There's 8 up top, there's 5 in the bottom, so how many are left up top? 3. You with me on that?
Yeah.
All right, we just add the exponents. 5 plus 3 was 8, 3 plus 2 was 5, subtract the bigger number, 8 was in the top, so x's stay up top. Y's, I got how many in the top? 7, how many in the bottom? 12. So these 7 could all cancel, right? And I got 5 left in the bottom. So my answer is 5x cubed over 3y to the 5th. Okay? It says assume that all expressions are defined. That means I don't have to write the restrictions, right? Does that make sense? So again, you cannot do it this way when there's minuses and pluses. Okay, I told you that yesterday, didn't I? Yeah, and did some of you do that yesterday? Yeah. Why don't you guys believe it? Have I lied to you a lot this year?
Yes.
Oh, I have? I'm sorry about that. Then. Who had a question? Hey, Ken. What do you mean, 2? I did. 3 goes into 3 once, and 3 goes into 9 3 times. 2 goes into 2 once, 2 goes into 10 5. So 1 times 5 is the 5, and 1 times 3 is the 3. Does that answer your question? Okay. Any other questions on that one? Okay. Can I factor x minus 3? No. Can I factor 4x plus 20? Yeah, because there's a 4 that goes into both, right? A GCF. Okay? So 4 times, you good with that? 4 times x plus 5? Factor out the 4. 4 goes, x divided by 4 is 1x. 20 divided by 4 is 5, right? Can I factor x plus 5? No. How about x squared minus 9? What do we call that? Difference of squares. How many sets of parentheses do we do? 2. What goes in the front of both? X, the square root of x squared. What goes in the back of both? 3, the square root of 9. One is plus and one is minus. And then the x minus 3's will cancel. The x plus 5's cancel. If there's nothing left up top, it's not 0, it's what? 1. You know, when you divide, something divided by itself is a 1, right? We just usually don't write those 1s in there. Okay? Does that one make sense? So it's basically the same as last night, right? You're just doing 2 fractions. And you're canceling. And the stuff in top stays up top, the stuff in the bottom stays in the bottom. Last night we just had 1 fraction, right? We canceled stuff top and bottom. Question. So it's really nothing different than yesterday. All right, so can we handle that? Do I have to do any factoring here? No. Okay, what number goes into 15 and 20? 5, right? So I have a, oops, I didn't go back to my pen, right? 5. Into that is not 5. What did you guys tell me? You told me 3, didn't you? And what's 5 into 20? 4. Is there a number that goes into 2 and 4? 2. So 2 into 2, 2 into 4, 2. How many X's up top? 8. How many in the bottom? 5. So where are they going to end up? How many? All right, so there's going to be 3 X's up top, right? So the bottom is 3 times 1, which is 3, and the top is 2x to the third. Okay? What happens here? What is the GCF? 10, right? Whoa!
It just doesn't like you to do
It does that all the time to me, doesn't it? And I don't like it. X minus 4. Good. What can I multiply to get 8 and add to get negative 6? Negative 4 and a negative 2. Good. 2 negatives make it positive 8, right? What about the x plus 3? No. What about 5x plus 15? 5, right? What's left? X plus 3. You guys see any things we could cancel? X minus 4s? X plus 3? Anything else? How about the 10 and the 5? Right, we could, right? 10 and the 5 also. So the 5 becomes a 1, the 10 became a 2, right? So the top is what? 2, and the bottom is x minus 2. That making sense? Again, we have to factor first when we have pluses and minuses, like the right side. You do not have to factor when there's no pluses or minuses. It's already factored. See the difference between those examples? All right, so we just have to factor and cancel factors. Simple. All right? When you divide, what do you end up doing? Multiplying by the reciprocal, right? So every division problem is actually a multiplication problem. So even though we're talking about multiplying and dividing, we're actually just multiplying. So when you write the problem, a division problem, you just need to rewrite it as a multiplication, and you flip the second one, the one to the right of the division sign. The one to the left, you don't do anything to. Over here, I get kids will flip this one instead. I don't do that. I'm not lying to you, that's what I do. Right? Times the reciprocal. So even though you read it in the book or on the practice quiz or the quiz as division, write it down as multiplication. Okay? Multiplied by the reciprocal. All right? So what do I got to do with this one here? Flip it. I need to say it's 5x to the 4th over 8x squared y squared times 8y to the 5th over 15. That's what I'm thinking. Now do everything else what we've been doing. Okay, what happens to the 8's? Cancel. 5 and 15 become what? A 1 and a 3. Those are 1s, right? Where's the x's going to be? Top. How many? 2 of them, right? We'll just do this, right? X squared. How about the y's? Top or bottom? top, how many? 3. So our answer is x squared y cubed over 3. This seem a little better than last night? But last night's not so bad now, is it? We're getting the hang of this, aren't we? Right, we're getting the hang of it? You sure? Making your head spin? Oh, okay. Well, if you stop doing that, maybe it won't spin. All right, we good? That's basically it. Oh, we also got some equations we got to solve. Again, what do we do with these two? Flip them. Here is it all factored out for you. Right? Difference of squares. Right? GCF of x squared. Positive 4, negative 2. Negative 1, negative 3. You guys can handle that. All right? But I want to show you an equation one. Here's an equation one. Okay? What do we call that top? That numerator? Difference of squares. What's it come out to be? X plus 5 and x minus 5. What happens to the x minus 5s? They cancel. Okay? What's it say after solve here? Check. Okay? So we did that. We cancel. So here's my problem. What do I do to finish it up? Subtract 5, right? What's 14 minus 5?
9.
9, right? By check, they want you to substitute into the original problem. And just check the denominator. What's 9 minus 5? 4. Is it okay to have a 4 in the denominator? Yeah. What is not allowed to have in the denominator? 0. Sometimes when you get this answer and you plug it in the original, you get 0 in there. Then you're going to say, no solution. That's not a good solution that you got. Okay? So you simplify the fraction first. And what happens always is the bottom gets canceled out. And whatever's left in the top is equal to this number. Solve for x and then check it. Okay? If you don't get 0, that's a good answer. If you do get 0, then it's not a good answer. There'll be no solution. Okay, there's the check. That's okay. Here's 1. We got 2. This was x plus 5, x minus 2. The x minus 2's go away. When I put 2 right there, what happened? You got 0. So is 2 a good answer? No. Right? That's no good. What happened? So there's no solution. Okay, that'll happen more than you think on these. So check for that. All right? All right, that's it. Sorry, I forgot about that. Okay. What do you guys do? You guys got some electric mojo that messes with my stuff? All right. So your homework is page 580 again. 8 to 16 even. And number 38. I'll get it back up here in a second. 8 to 16 even and number 38, page 580. There you go.